Hello, and welcome to the C programming lecture on Boolean expressions and relational operators. What are Boolean values? Boolean, or bool for short, are values expressed as either true or false. These values are typically used inside of our control structures, things like selection or looping. And in C, Boolean values are not primitive values like integers or floats, rather they're implemented by the standard library. So here's a program example of how to use a Boolean. We can see that we include the header file stdbool.h. We can also see that we are implementing some variables, or just one variable, x, and we're printing out the value of x. So we can see the default value is 0, and when we declare a bool and when we set it to true, we have a relationship with the value 1. Then again, we set it to false, print that out, and we can see that it's 0. So what are relational operators? In C, relational operators give the programmer the ability to ask questions like what is the value at variable x? Is it greater than or equal to the variable and value y? So it just allows us to express questions and receive true or false values of those questions. So here are some examples of what we can use. We can say greater than or equal to, less than or equal to, or not equal to. And again, doing these things will give us a Boolean result. So a Boolean expression are expressions created using relational operators, something like I just talked about before. So we could write code that asks the computer to evaluate whether a variable at, let's say, named x is greater than the value at a variable named y, and the result will be a true or false value. But again, we can think of these true or false values as integer values, 1 for true, 0 for false. So again, here is now some Boolean expression examples. We are using each of the relational operators, and we're printing them out here. We have x set to 10, y set to 2, and you can see that, as expected, some of these are true and some are false. You can kind of read through and skim through these to see what makes sense. We can do the first few, and I'll leave it up to you to just review the rest. So we can see that the first one is the first expression is false because x does not equal y, clearly. 10 does not equal 2, and we can see that the second one, the second expression, does not equal evaluates to true. So again, these first two are correct, and I'll let you go ahead and step through the rest of these to get a better grasp of which of these, what these relational operators do and what Boolean expression it results in. So now we can talk about Boolean assignment with expressions. So kind of like what we did before in our previous slide where we were just printing them out, now we're assigning a true or false value on the other end of a variable. So we can have the x value equal to 10, y equal to 5, and we can create an expression and store the result inside of the variable t, a Boolean result, whether it's true or false. So we can see that we can say something like, is 10 greater than y, and that should result in true. So t should be the value 1. We can see that here in our output. And we can see that we try this with a constant for the variable f, and this should result in false because 20 is not less than 10, right? So we see here it's a 0. So final words for Booleans. Booleans allow us to, and we'll see the power of this inside of control structures. Really, it's just going to be us evaluating expressions that are true or false that allow us to enter a particular if statement or continue a looping statement. So be curious, spend some time comparing different primitive types to see if they have different results. Just play around with this stuff. We can enter into a coding session and also do that as well. Okay, let's go ahead and get started with some of our coding examples. The first things we're going to do is we're going to go ahead and make a file named main.c. We're going to go ahead and open up that file inside of our code editor and put our normal hello world application in here. So first we have our include statement, then we have our main function. I'm going to go ahead and just print hello world. And again, I kind of like to do this because it just gives me a good base to work with. And the more frequently you do this for new projects, the faster it gets spun up. So, all right, let's go ahead and do some Boolean values here. Now, the first thing we're going to want to do is include std bool.h. And next let's go ahead and just say bool t, and let's make it true. And let's say bool f equals false. And now what we'll do is let's go ahead and print these values out. We can say something along the lines of like t, make that a %d with a new line, pass in our t, copy this guy, paste, and let's print out f and set the variable to f. Now let's go back to our terminal, recompile the program, run it, and we can see, just as we expected, these two values are printing out true, which is 1, and false, which is 0. So now let's just create some more complicated, I guess, expressions. So bool x is equal to, let's say, 20, which is greater than 5. So this is true. And then what we can do, we can say something like x is equal to x. So true, and so, let's print this out first, actually. X like that. Let's reassign x. So what else can we do? We can say, let's say 21 plus 9 is equal to 30. And then we'll print out x. So let's go ahead and start with these and see what's going to happen. So let's make sure this program compiles. It does. So let's just evaluate this program real quick to see what we think is going to print out. So we already know these first two, so we'll ignore them. Now let's think about this. 20 is greater than 5. This is true, so we expect x to print out 1 here. And then in this expression, we're saying 21 plus 9 is equal to 30. So this should also evaluate to true. So let's go ahead and run the program. We should see x is equal to 1 twice. And that indeed we do. So let's go ahead and take this expression. And let's say it's equal to 31. Print out. Now we should see this line be 0. GCC main.c, go ahead and run it, and yep, that's exactly what we see. So go ahead and play around with this. Remember that we have other relational operators. We have, greater than or equal to, less than or equal to, a bunch of different ones that you guys can mess around with. You can continue down this path and figure out what each one may do. Integer values are typically easiest to use, but we can notice something kind of interesting, I guess. Let's do one more case. Let's just use some floating point values. So we can say let's do the same example here, but use floating point values. So let's say 21.0 plus 9.0 is equal to 30.0. And let's add some f's so we know we can tell the compiler that these are floats. And let's print this out and see what we get. And we get a true. So in some cases, this precision will evaluate to true, but if, for instance, if this was, something along these lines, it may not be the case. So yeah, right, because we're comparing something that's not quite equal to 30.0. So again, like in some instances, it makes sense to do something like, let's say, floor the result and then compare it, or something along those lines. But just keep that in mind that, numerical precision does affect the comparison of our Boolean expressions.